Hey, Wagwan, it's Mr. Garfield here, and we're going to be looking at a Cape Pure Mathematics Unit 1 question. All right, and I'm focusing on Module 3, that's Calculus 1. Okay, and we have a May June 2016 Paper 3 stationary point question, the application of stationary points. All right, now this question is 15 marks. Okay, the first part of the question is 5 marks and the second part of the question is 10 marks. Okay, now before we get started, please ensure to like the video right now. Right, so go and like up the video and you can also comment down below when you're finished. Okay, so we have a calculus question here. All right, and I have to say that it is one of the most difficult questions, one of the most difficult calculus questions I have ever seen CXC put on the pure math paper, right? I think this is the most difficult question I've ever seen them put on a pure mathematics paper for unit 1, that is, right? So here to the left, it says diagram A, all right? This is the diagram A that they're talking about. It's not drawn to scale, and it shows the design of a trough. Not sure if I'm pronouncing that correctly, but yes, it's a trough. The cross section of the trough, which has the shape of a trapezium, is shown in diagram B. All right, so this is the diagram B here. And it says all lengths are in meters. Okay, good. So here we have the questions to the side, and it says, the first part of the question says, given that the volume V is the product of the cross-sectional area and the length of the trough, show that V is equal to 10 cos theta multiplied by 1 plus sine theta. Part 2 of the question says, hence or otherwise, determine the maximum possible volume of the trough. All right, so let us do part 1. Okay, as I told you, it's a 15-mark question. Part 1 that we're going to attempt now is 5 marks, and part 2 of the question is 10 marks. Okay, so we're going to be here for a while. All right, so down here it says that the trough must be made using the dimensions above, but the angle theta may vary. All right, great. So let's just do part 1 solution here. All right, so this is part 1 solution. Let's look back at part 1. It says that given that the volume V is a product of the cross-sectional area and the length of the trough, show that V is equal to that. All right, so we need to find the volume of the trough. Okay, so what I'm going to do is find the cross-sectional area first. Right, the area of the cross-section. Okay, so I need to find the area of this figure here, B. Okay, which has the shape of a trapezium as they told us in the question. So if you look carefully, if I want to find the area of this diagram, I would have to calculate the area of this triangle here, right? This right angle triangle, which is the same right angle triangle here at the end as well, okay? And I need to also find the area of this rectangle here, okay? Let's do that. So we have part 1 solution. All right, so what I'm going to do here is just to label the diagram, parts of the diagram, right? This side, which is the base of the triangle, all right, we don't know what that is, so I'm just gonna call it B for base. All right, so we're calling it B for base, okay? And in order to find B, I need to use up my knowledge of trigonometric ratios, okay? Good. So if I want to find cos theta, if I want to find theta, right? If I want to find the side here, which is B, I would have to use my knowledge of trig ratios. So I can say that cos theta is equal to what? the adjacent side divided by the hypotenuse, right? So I can say that cos theta is equal to the adjacent side divided by the hypotenuse. So what is the adjacent side? The adjacent side here is h, right? And the hypotenuse is 1. So what I have is cos theta being equal to h divided by 1, all right? I just want to find what is h first, and then I'm going to go back to find b. Okay, so I have h divided by 1, which we can write as h, right? So I can say that h is equal to cos theta. Okay, because in order to find the area, I need to know what the side h is, and I need to know what the side b is. All right, in terms of theta, because we're dealing with trigonometric functions here. All right, so h is equal to cos theta. Let us now find b. All right, what is the side b? Well, I know that sine of my angle theta is going to be the opposite side divided by the hypotenuse, right? So the opposite side here is b, all right? And the hypotenuse has a length of 1 meters, all right? So I can also say that sine theta is equal to b divided by 1, all right? And I can therefore say that b is equal to sine theta. Okay, good. So we know what h is and we know what b is. Great. So we can now proceed to find the area. All right. So you recognize that I have two right angle triangles. So I need to find the area of one. All right. I need to find the area and then multiply by 2 or just add it again. So just find the area of this right angle triangle. I know that the area of the triangle is a half multiplied by the base b multiplied by the perpendicular height h. All right. Let's write that down. So we're finding the area of the diagram b. Okay, so the area is going to be equal to a half multiplied by the base b, which we know is sine theta, multiplied by the perpendicular height h, which we know is cos theta. Okay, and remember I have another triangle as well. I have the same right angle triangle, so I can just say plus a half sine theta cos theta again, right? Because I have two of those triangles. Great. And let me now find the area of this rectangle. So it's going to be the length multiplied by the width. So it's going to be h multiplied by 1, which is h, right? So h multiplied by 1, which is h, and we know that h is cos theta. So we're just going to have plus cos theta here. Okay? So that is my area of the diagram B. All right? So I'm just going to simplify now. So the area is equal to a half sine theta plus a half sine theta, just 1 sine theta, right? 1 sine theta cos theta, sorry. Right? A half sine theta cos theta plus a half sine theta cos theta is 1 sine theta cos theta. Right? Because we know that a half plus a half is 1. So we have 1 sine theta cos theta there. Plus, we still have the cos theta at the end. Okay, good. So the area is equal to, now you clearly can see that cos theta is here and cos theta is here. So it means that cos theta is a common factor. So I'm going to factor out the cos theta. Okay. And when I do that, I will have sine theta plus 1 remaining in the brackets. Okay. So that is the area of the cross section. All right. And we're going to have the length of the cross section, the length of the trough, sorry, which is 10. Right? Because remember, it told us that the volume is the product of the cross-sectional area and the length of the trough, right? So let me just write that down. All right, I'm just gonna write that down here. So they told us that the volume V is equal to the area of the cross section, multiplied by the length of the throat, right? That's what they told us. So we know that the area of the cross section is what we just calculated previously. That's cos theta multiplied by sine theta plus 1 or 1 plus sine theta, right? Just switching it around, not changing anything, right? So it's cos theta multiplied by 1 plus sine theta multiplied by the length, and the length of the throw here is 10 meters, all right? 10 meters. So we're now going to multiply that by 10, okay? So therefore, we get V, the volume, to be equal to 10 times cos theta multiplied by 1 plus sine theta. Okay? And let's look back at the question. They told us that to show that V is equal to 10 cos theta times 1 plus sine theta, and that is what we just shown, right? So I can now come back here. I can now come back here and say shown, right? So I'm now going to say shown. Okay? Good. And once you have done that, it means that you have obtained your full 5 marks for this question, okay? Great. Just know the part 2 of the question. All right, part 2 of the question, I have to be honest with you, it's a bit long, all right, but we're going to go through it together step by step. So part 1 of the question was 5 marks. We're going to now attempt part 2, which is 10 marks. All right, that's 10 marks. So part 2 of the question says, hence or otherwise determine the maximum possible volume of the throw. Now, how do we do that now? Well, you'd have to remember your knowledge from stationary points, right? You have to use your knowledge from stationary points here, okay? So what do you know about stationary points? We know that at dv by d theta, right? That's the first derivative of v with respect to theta. At dv by d theta, it is equal to 0, right? The stationary points, the first derivative is equal to 0, correct? So it means that I need to find dv by d theta, right? The first derivative of v with respect to theta. And then I'm going to have to equate that derivative to 0 in order to find my values for theta, okay? So you need to apply your knowledge of stationary points here. So let me write part 2 solution. Part 2 solution. Good. So we know that V is equal to 10 times cos theta multiplied by 1 plus sine theta. All right, we know that. So I'm now going to find the derivative of V with respect to theta. Okay, that's now going to be dV by d theta. All right, so you realize that I'm multiplying two functions. Okay, so I'm going to have to use the product rule. Okay, so the product rule says what? V in this case is 1 plus sine theta. So V multiplied by du, all right, so d by v theta of u in this case is 10 cos theta, all right, plus u, which is 10 cos theta, multiplied by dv. So that's d by d theta of v. V in this case is 1 plus sine theta. Right? You should remember your product rule formula. Okay, great. So we're now going to have to simplify now. This is now equal to, when you differentiate cos theta, you get a negative sine theta, right? So what you're going to have here is just a negative 10 sine theta for the derivative. Okay, so that's negative 10 sine theta. And you're multiplying that by the 1 plus sine theta on the outside. Okay, plus 10 cos theta multiplied by the derivative of 1 plus sine theta. When you differentiate 1 with respect to theta, you get 0, right? When you differentiate a constant, you get 0. And when you differentiate sine theta, you get cos theta. All right, so those are things that you should know. Great. So let us now simplify. All right, so negative 10 sine theta multiplied by 1, that's negative 10 sine theta. And negative 10 sine theta multiplied by the sine theta will give us a negative 10 sine squared theta. Okay? Plus 0 plus cos theta is just cos theta. So what we have is 10 cos theta being multiplied by cos theta, which will give me a 10 cos squared theta. Okay? And this is now equal to, I now have negative 10 sine theta minus 10 sine squared theta plus 10 cos squared theta. All right, remember I want my value for theta, so I have to equate the derivative to 0 to find my value for theta. But you recognize that I have sine and I have cosine. I want it in terms of either sine or cosine only, okay? So I see that I can convert cos squared theta into sine, right, in terms of sine. So if you remember your Pythagorean identity, it says that sine squared theta plus cos squared theta equals 1, right? And that would imply that cos squared theta is equal to 1 minus sine squared theta. Okay, so I'm just going to replace cos squared theta with 1 minus sine squared theta. All right, so negative 10 sine theta plus, sorry, that's a minus. All right, minus 10 sine squared theta plus 10, and we're multiplying that by 1 minus sine squared theta. Everybody should know that identity by now. All right, so I'm now going to simplify everything. So I now have negative 10 sine theta, all right, minus 10 sine squared theta. 10 multiplied by 1 is 10, and 10 multiplied by negative sine squared theta is negative 10 sine squared theta. Okay, good. So I can now say that dv by d theta is equal to, I am going to put the 10 in front since it is positive. Then I'm going to put the negative 10 sine theta after. Okay, and you recognize that I have negative 10 sine squared theta minus 10 sine squared theta. That will give me a negative 20 sine squared theta. Okay, and that is my derivative of v with respect to theta. Great. So now that we have the derivative, let us now equate it to 0 and find the values of theta. All right. So we know that at stationary points, so I'm just going to write a statement here. At stationary points, dv by d theta must be equal to 0, right? We know that. So if dv by d theta is equal to 0, it implies that 10 minus 10 sine theta minus 20 sine squared theta is equal to 0. Okay, so just equating dv by d theta to 0, all right? And I'm now going to proceed to find the values of theta. Okay, now immediately I recognize that 10 is a common factor, okay? And I want the coefficient of the sine squared theta to be a positive number, okay? So what I'm going to do is to divide the equation by negative 10. All right, so I'm going to divide the left-hand side by negative 10, and I'm going to divide the right-hand side of the equation by negative 10 also. So when I divide negative 20 sine squared theta by a negative 10, I will get a positive 2 sine squared theta. Okay, And when I divide negative 10 sine theta by negative 10, I will get a positive sine theta. And when I divide 10 by a negative 10, I will get a negative 1. Okay? And when I divide 0 by negative 10, of course, we get 0 on the right-hand side. Okay? Great. Now, if you observe carefully, we have a quadratic equation here, all right, in terms of sine theta. So I'm going to solve this quadratic equation, okay, by using the method of factorization. So I'm going to factorize the quadratic expression on the left-hand side, okay? Great. So let me just write some stuff here. The product, right? The product is going to be the multiplication of 2 and negative 1. So that's 2 multiplied by negative 1, which will give me a negative 2. And I need a sum of 1, right? 1 is the coefficient of sine theta there. Great. So I need two numbers. When I multiply them, I get negative 2. And when I add them, I get positive 1. All right. And those two numbers are 2 and negative 1. All right. 2 multiplied by negative 1 will give me a negative 2. And 2 plus negative 1 will give me 1. Right? Great. So let us now continue. So I'm not going to split the middle term. I'm going to split sine theta into 2 sine theta minus sine theta. All right. So what I now have is 2 sine squared theta here, splitting the sine theta as 2, positive 2 sine theta minus 1 sine theta. All right. And remember that I have a minus 1 there at the end as my constant, and that is equal to 0. Great. Let us now factorize. Now, if you look carefully for the first two terms here, all right, for the first two terms here, you recognize that 2 is common and sine theta is also common, right? So I can factor out a 2 sine theta there. So I'm going to factor out a 2 sine theta. And if I do that in brackets, I'm going to have sine theta plus 1. All right, that is what we're going to have left. Okay, and if I now look at these two terms here, okay, you can see that negative 1 is a common factor. So I'm going to factor out a negative 1. When I factor out a negative 1 in brackets, I'm going to have sine theta plus 1. And that is equal to 0, right? And of course, we know that we are on the right track because you can clearly see that in the brackets, we have the same thing, right? We have sine theta plus 1 in both brackets. So we know that we have factorized well. So clearly you can see that sine theta plus 1 is here and sine theta plus 1 is here. All right, so it means that sine theta plus 1 is now common. So I'm going to factor out sine theta plus 1. All right, factoring out sine theta plus 1. Great, sine theta plus 1. And what I'm going to have now in the other bracket is what is on the outside, which is 2 sine theta minus 1. That equals 0. Great. So I now have a product equal to 0. All right, and I need to find my values of theta. So if I have sine theta plus 1 multiplied by 2 sine theta minus 1 being equal to 0, then it means that either the first one equals 0, so either sine theta plus 1 equals 0, or the second one equals 0, right? So or 2 sine theta minus 1 equals 0. Good. So I'm now going to solve these equations here. All right, so I'm going to carry the positive 1 to the right-hand side. It will become a negative 1. So either sine theta equals negative 1, or if I make sine theta the subject of this equation, I will get sine theta to be equal to 1 divided by 2. All right, so either sine theta equals negative 1 or sine theta equals a half. All right, great. That is what I have. So I need to know solve these equations. Okay? So I have sine theta equals -1. Okay? Now what is going to be my answer for that? Okay? Now notice, let's go back to the question. Notice there is nowhere in the question that says that theta is greater than or equal to some number, but less than or equal to some number, right? They didn't give us an interval for theta, okay? They didn't give us any interval for theta. They didn't give us any restriction. So we know that whenever we're not given any restriction, it means that we're going to have an infinite set of values, right? Or an infinite set of solutions, right? So it means that I need to generate a general solution for these two equations, okay? So I have sine theta equals -1. What are going to be my solutions for that? All right. So I'm just going to use my mathematics software now and show you the graph of sine theta. All right. And we're going to find the solution when sine theta equals -1. Okay. So I'm just going to share my screen here. Great. So you should be seeing my screen now. All right. Yes. You should be seeing my screen. So this is the graph, this black curve that you see here. This is the graph of sine theta. All right, and this horizontal axis is my theta axis. All right, and the vertical axis here is my sine theta axis or my y-axis. Okay, so remember that I need to find my value for sine theta equals -1. So in order to do that, what I'm going to do is to just draw a -1 line here. Right, I'm going to draw a horizontal line through -1. Okay, and anywhere that the line and the curve intersects, that is where my solutions are. Okay, so let me just come over here now. I already have it hidden, so I'm going to pop it up. So y equals -1. Great. That is my red line here. All right, that is my red line here. Okay, so clearly you can see that the curve intersects with this graph. All right, so let's just look at the solutions here. So we have 3 pi over 2 as a solution, right? We have 3 pi over 2 radians as a solution. We have 7 pi over 2 as a solution, right? And we have 11 pi over 2 here as a solution, right? And it goes on and on forever. Okay, great. That's the positive direction. Over to the negative side, right? You see that I have negative pi over 2 as a solution, all right? And I have negative 5 pi over 2 as a solution, and so on, right? So that is what I have. Great. That is what I have. All right. So how can I now generate the solution for that? All right. How can I now generate the solution for that? So I'm going to go back now to the paper that we were working with. Right. So clearly we can see that we had theta as 3 pi over 2. All right, we had theta equals 3 pi over 2. We had 7 pi over 2. All right, we had 7 pi over 2. We had 11 pi over 2. All right, and I believe we also had negative pi over 2. And we had many other values, right? So we have an infinite set of solutions. Okay, great. So I'm now just going to generate the general solution for this, okay, for the solutions. So I'm aware that many students use a formula, right, to generate the general solution, but I'm not going to use a formula because based on the solutions that you're getting, right, you must observe that there is some kind of pattern, right? there you must generate the solution based on the pattern that you're seeing, right? Sometimes we can see that it we have a we're adding something, right, with a multiple of 2 pi. All right, sometimes we're adding with a multiple of pi, right? So it's up to you. You have to look at the solution, right, and observe the pattern, or you could use the formula that you have learned in school. All right, I'm not going to use a formula, but based on what I'm seeing here, it means that my general solution is going to be 3 pi divided by 2. All right, so I'm going to have 3 pi divided by 2 plus 2n pi. All right, where n belongs to the set of integers. Okay, great. That is my general solution for this trig equation, right? Sine theta equals -1. Great. So that is my general solution. Let us now focus on the other equation, which is sine theta equals a half. All right, so we have sine theta. We have sine theta equals a half. Okay, great. So theta is going to be equal to what? So I'm going to go back to my graph again for sine theta. All right, you could use a calculator as well if you're mathematically inclined. You can use the calculator and your knowledge of trigonometry to find the values of theta as well, right? But I just wanted to get the visual representation. All right, so I'm gonna go back to my graph. So you should be seeing my graph now. Okay, and I'm gonna hide that red line there. All right, so I'm gonna hide that red line, and I'm now going to want y equals a half. Okay, so that is the red line that you see there above the x-axis. Okay, great. So anywhere that the line intersects with the black curve, you know that that is going to be a solution, right? So what I have is pi over 6 as a solution. I have 5 pi over 6 as a solution. All right, let's go over here now. We have 13 pi over 6 as a solution. We have 17 pi over 6 as a solution. We have 25 pi over 6 as a solution, and so on. Right, that is to the right of 0. To the left of 0 now, I'm going to have -7 pi over 6 as a solution. I'm going to have -11 pi over 6 as a solution. I'm going to have -19 pi over 6 as a solution, and so on, right? So I have an infinite set of solutions. Okay, great. So I'm just going to write down some of them here. So I'm just going to write down some of them. All right. So let's go back now to the paper that we're working with. Great. So you should be seeing my screen again. All right. So from our observation from the diagram, we can see that theta equals pi over 6. Right? We had pi over 6 as a solution. We had 5 pi over 6 as a solution. We had -7 pi over 6 as a solution, and so on. Right? We have an infinite set of solutions. Okay? So based on what I'm seeing here, all right, based on what I'm seeing here, I can generate 2 general solutions for this equation, right? So I'm now going to say that theta, my general solution is theta equals pi over 6 plus 2n pi, all right? And theta is equal to 5 pi over 6, okay? And theta equals 5 pi over 6 plus 2n pi, all right? Where n belongs to this set of integers. All right, so you have to specify what n is. So n represents an integer, right? It's a member of the set of integers. Good. So that is my solution, right? You could test it out, you know. You could substitute integer values for n inside of theta, and you will see that you will get the same solution that I've written here. All right, great. So we have our values for theta. Now, excellent. Now we need to find which one of these will give us a maximum value of the throw. All right, we're gonna see which one of these gives us a maximum volume of the throw. Okay, so what I'm going to do is to test, right? I'm going to test which one of these is the maximum, right? And we're going to test which one of these is the maximum, and then we can basically write down what is the maximum possible volume of the throw. Okay? Now, there are different ways you could do the test. You could use either the gradient test or the second derivative test. All right? So I'm going to use the second derivative test, okay, to test which one of these is a maximum. All right? So I am now going to find the second derivative. Okay? So I'm now going to say d2v by d theta squared. All right? d2v by d theta squared. Okay, we're just finding the second derivative of v with respect to theta. All right, so that is equal to d by d theta of dv by d theta. So we're differentiating dv by d theta with respect to theta. That's what that means, okay? This is now equal to d by d theta of, now let's go back up here. All right, we're going to go back up. So we got dv by d theta to be 10 minus 10 sine theta minus 20 sine squared theta. All right, so let's do that. Let's write that in here. So that's 10 minus 10 sine theta minus 20 sine squared theta. Okay, good. So I'm now going to differentiate each term with respect to theta. We know that when we differentiate a constant, we're supposed to get 0, right? So when you differentiate 10 with respect to theta, we get 0, okay? And when we differentiate negative 10 sine theta, all right, we're gonna get what? Negative 10 cos theta, right? Because we know that when we differentiate sine, we get cos. Good. And we're now going to differentiate negative 20 sine squared theta, all right? So I'm going to use the extension of the power rule, which says that if I have a function being raised to a power, to a real number power, I can carry down that power, right, and multiply by the coefficient. So that's negative 20 multiplied by the 2, which will give me a negative 40. Write back the base, which is sine theta. Decrease the power by 1, so 2 minus 1 will give me 1 as the power for sine theta, right? And I need to multiply by the derivative of sine theta as well, which is cos theta. Okay, so that is my second derivative. Let's just simplify here. All right, so this is now equal to, I recognize that negative 10 cos theta is a common factor for the two last terms here. So I can factor that out. Okay, so I can say that d2v by d theta squared equals negative 10 cos theta. And in brackets, I'm going to have 1 plus 4 sine theta remaining. All right, that is my second derivative of v with respect to theta. Great. That is what I have. Now, I need to test which one of these values for theta here, right? Which one of these, out of the three, I need to find which one of these will give us a maximum, right? So I'm now going to substitute these values now into the second derivative, okay? So the first one that we had calculated is theta equals 3 pi over 2 plus 2n pi. All right, so when theta equals 3 pi over 2 plus 2n pi, the second derivative, d2v by d theta squared, equals negative 10 times the cos of theta, right? Theta is 3 pi over 2 plus 2n pi, all right? Multiplied by 1 plus 4 sine theta, all right? And theta is 3 pi over 2 plus 2n pi. Okay, great. Now, when I do this, persons might wonder, sir, what are you doing, right? But yes, we have to substitute that value into the second derivative, right? So you probably might be wondering, what is the next step here? How are you going to find the cos of that angle and the sine of that angle, right? So all you have to do is choose a value for n. Choose an integer value for n, okay? So you can put into your calculator negative 10 cos, all right, of 3 pi over 2, all right, because it's better to work with it when n is 0, right, so that you don't have to punch in any extra digit into the calculator. All right, so let's take a simple case when n is 0, we're left with 3 pi over 2, right? So you can plug into your calculator negative 10 cosine of 3 pi over 2 multiplied by 1 plus 4 sine of 3 pi over 2. Okay? So ensure that when you do that, though, your scientific calculator is in radian mode. Okay? Great. Because if you're working with degrees, if your calculator is in degree mode, then it means that you'd have to convert this theta here into degrees. All right? But we're working with it in radians, so you need to ensure that your scientific calculator is in radian mode. All right? So when you plug in that now, what I've said previously, into your scientific calculator, you will get d2v by d theta squared to be equal to 0. All right? Now, what does that mean? What does that mean? When we substitute a stationary point into the second derivative and we get 0, what does that mean? All right, so I'm going to write a statement here and say, since the second derivative of v with respect to theta, all right, since that is equal to 0, all right, it implies that at theta equals 3 pi over 2 plus 2n pi, we have a what? We have a possible point of inflection, all right? We have a possible point of inflection. Okay, that is what it means. We have a possible point of inflection. Great. So just now proceed to the other value of theta. All right, so this is when theta equals pi over 6. All right, pi over 6 plus 2n pi. Okay, pi over 6 plus 2n pi. So what am I going to know how? So I can therefore say that dv, right, d2v by d theta squared is equal to negative 10 times the cosine of theta, which is pi over 6 plus 2n pi. All right, that is what we're going to have. And we're going to multiply that now by 1 plus 4 times the sine of theta, which is pi over 6 plus 2n pi. All right, plus 2n pi. Great. That is what we have. Now, if you substitute that inside for theta, right? If you substitute that angle inside for theta, and you put into your calculator, you just choose a value for n. So in the simplest case, n is 0. So you can work with negative 10 times the cos of pi over 6 multiplied by 1 plus 4 times the sine of pi over 6. Right? If you put that into your calculator, you will get, some persons might get a decimal, all right, depending on the calculator that they have used, all right, that they are using, but the actual value is negative 15 multiplied by the square root of 3. Okay? That is the answer you get. All right? So let us just now write what that means. So what can we say now? Since the second derivative, so I can say that since d2v by d theta squared, all right, is less than 0, what does that mean? All right, it implies at theta equals pi over 6 plus 2n pi, right? We have a what? Is it a maximum or is it a minimum? It is going to be a maximum point, all right? We're gonna have a maximum point. Okay, great. Now, normally when we're working with polynomials, and with polynomials or rational functions, right, or different types of functions, we normally put the word local or relative maximum point, right? But in this case, I'm only putting the word maximum, all right? I'm only putting the word maximum point, okay? I'm only putting in the word maximum point in this case. Okay, so we have a maximum point there. I just now test the other solution. Okay, so when theta equals, so this is the last one, when theta equals 5 pi divided by 6 plus 2n pi, right? What is this second derivative? The d2v by d theta squared is equal to negative 10 times the cos of theta, which is 5 pi over 6 plus 2n pi, all right, multiplied by 1 plus 4 times the sine of theta, which is 5 pi over 6 plus 2n pi. All right, great. That is what we have. So remember, all you have to do is just pick a value for n. All right, pick a value for n. When n is 0, we're going to be left with 5 pi over 6, right? That's one case. That's one solution, right? So we're going to have negative 10 times the cos of 5 pi over 6 times 1 plus 4 times the sine of 5 pi over 6. Okay? And if you do that, you should get a positive 15 root 3, right? So 15 times the square root of 3. Good. So our value there is positive, right? So what can we say? So I can now say that since the second derivative of v with respect to theta, all right, so since the second derivative is greater than 0, it is positive, it implies that at theta equals 5 pi over 6 plus 2n pi, right, we have a what? We have a minimum point. All right, we have a minimum point. Okay, good. So that is my answers. All right, so I'm just going to now pop up my mathematics software and show you that these are actually indeed true. Okay, so I'm going to draw the graph of V, all right, the volume graph, and then we're going to show you that the nature of these stationary points are actually indeed true. All right, so I just want to get the visual understanding. Okay, so you should be seeing my screen now. All right, so I'm going to hide the sine wave and the red line there. I'm now going to pop up the volume graph. All right, so let me just zoom out a bit. All right, I'm going to zoom out a bit so that you see the full graph. Right, that is actually the graph of V, right, or volume V, which was what? It was 10 cos theta multiplied by 1 plus sine theta, right? That is the graph. Okay, that is my graph. Great. And remember that we said that at the point 3 pi plus 2n pi, we're going to have a possible point of inflection, right? So clearly you can see that, right? So let's take the first case when n is 1, when n is 0, sorry. All right. Let's look at a simple case when n is 0. We're going to have 3 pi over 2, right? So let's look for 3 pi over 2 here. All right. We're going to look for 3 pi over 2, which is right here, right? You can see that this is a point of inflection, right? It's indeed a point of inflection because you have the gradient here being negative, right? So you have negative gradient here, then 0 gradient here, then positive gradient here, right? So the graph changes from negative to 0 to positive, right? So we know that we indeed have a point of inflection, okay? And here's another one, point of inflection, right? Here's another one, point of inflection, and so on, okay? And so on. Great. Now, in the other angle, right, theta equals pi over 6 plus 2n pi, okay? We stated that we're going to have a maximum point there, right? So let me just zoom out a bit. All right, I'm going to zoom out a bit here. Okay, great. And we're going to now look at negative 15 root 3. All right, negative 15 times the square root of 3. Okay. Sorry, at theta equals pi over 6 plus 2n pi, right? We got negative 15 root 3, right? That's what we got. All right, so let's look for pi over 6, right? N is 0. We're working with n as 0. So we're looking for pi over 6. All right. Yes, so we're working with n as 0. So we're looking for pi over 6. All right, this is pi over 6 here, right? And if we continue to go up, all right, let's go up, right up. All right, we have that value there, all right, which is indeed a maximum point, right? So we know that at pi over 6, we do have a maximum point for real, right? So at theta equals pi over 6 plus 2n pi, we're going to have a maximum point. Okay, great. And at theta equals 5 pi over 6, we're going to have a minimum point. All right, we're going to also have a minimum point. This is 5 pi over 6 right here. All right, 5 pi over 6. So if we go down, And let's go down, continue going down. You see that we do have a minimum point here, right? So at theta equals 5 pi over 6 plus 2n pi, we do indeed have a minimum point. All right, great. So let us go back to our working here. Okay, so you should be seeing my screen again. All right, great. So let me now find the maximum possible volume of the throw. All right, so I can now say that therefore the maximum possible volume of the throw is what? Remember that we had stated that the maximum point is going to be when theta equals 5 pi over 6 plus 2n pi, right? Good. So all we have to do now, in order to get the maximum possible volume of the throw, we're going to have to substitute theta equals pi over 6 plus 2n pi into the volume V, right? And see what answer we get. So the maximum possible volume of the throw is V equals, V was what? 10 cos theta multiplied by 1 plus sine theta, right? That's 10 times the cos of theta. In this case, our theta is 5 pi over 6 plus 2n pi. That is when we're going to have a maximum point, all right? Multiplied by 1 plus the sine, 1 plus the sine of what? So we're going to have 1 plus the sine of the angle theta, which is pi over 6 plus 2n pi. All right, good. That is what we have there. Okay, so this is now equal to, all right, so we can take a simple case. When n is 0, we're going to be left with pi over 6, right? So if you substitute 10 times the cos of pi over 6 multiplied by 1 plus the sine of pi over 6 into your scientific calculator, assuming that your scientific calculator is in radian mode, right? Some persons get a decimal, all right, but the actual value in third form is actually 15 root 3 divided by 15 root 3 divided by 2. All right, and remember that the length we're dealing with here is meters, right? And volume is in what? Cubic units, right? So the volume, the maximum possible volume of the throw is 15 root 3 over 2 cubic meters. All right, that is my answer. And we can verify it from the graph as well. So let me go back to the mathematics software, all right, that I'm using and show you that it is indeed true. Okay, so you should be seeing my screen again. All right, let me just zoom out a bit. All right, I'm going to zoom out a bit here. Great. And I'm saying that when V equals 15 root 3 over 2, right, that is going to be my maximum possible volume. Okay, so I already have it here, hidden CT right here, 15 root 3 over 2. So that is going to be the black line that you see above the x-axis there. Okay, great. And you can see that when we have V being equal to 15 root 3 over 2, we're going to get a maximum point, right? It intersects the volume V, right? The graph of V at every maximum point that you see here, right? So it means that my answer for the volume is indeed correct. All right, so my answer for the volume is 15 root 3 divided by 2 cubic meters. All right, let's go back to our working. Okay, right. So you should be seeing my screen again. Yes. So that is my answer. All right, so the possible volume of the throw is V equals 15 root 3 over 2 cubic meters. All right, ensure to like up the video and comment down below if it was helpful. All right, so we have now finished part 2 of this past paper question. All right, this is application of stationary points. Okay, I am Mr. Garth Reed, student ambassador in the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.